My name is Dan Behrens, and I'm a technical marketing engineer with Cisco's IoT business unit focused on our industrial security solutions. And today, we're going to dive into Cisco CyberVision. Cisco has developed an entire framework around bringing security to industrial environments. Leveraging Cisco's best-in-breed IT security solutions, along with Cisco CyberVision, organizations can identify what assets are deployed in their environment and what security policies make sense. So what is Cisco CyberVision? Cisco CyberVision is a solution that was developed specifically for industrial environments. Leveraging deep packet inspection and the ability to understand or decode industrial protocols, CyberVision can provide organizations with information as far as what assets are deployed in the environment, the communications that are occurring between those assets, and even what information is inside of those communications. Leveraging those asset details, CyberVision can also identify known vulnerabilities so organizations can recognize where they have vulnerable assets deployed. Using the vulnerability details along with what the device is and what the device is doing, CyberVision can also calculate a risk score so organizations can understand where their riskiest devices are and really where they should get started. Outside of security, CyberVision can also provide process-level details. Changes like a firmware update or a program download can quickly be identified, helping reduce the overall mean time to resolution when issues should occur. Cisco CyberVision is a two-tier architecture. The first tier is the CyberVision Center. This is where you as a user interface with the tool, where integrations with solutions both from Cisco as well as third-party occur, as well as a fully RESTful API for interacting with the solution. The other component is the CyberVision Sensor. This is the piece that actually performs the deep packet inspection and understands or decodes those industrial protocols, and it sends the information that it's learning back to the center in the format of what we refer to as application flow, or essentially metadata. That metadata makes up about 1 to 5% of the total traffic that the sensor is receiving, meaning if I'm sending about 100 megs of traffic to the sensor, I can expect about 1 to 5 megs of traffic communication from the sensor back to the center. The sensor is extremely lightweight and actually runs directly on Cisco networking equipment, as we'll discuss. This is important because in industrial environments, we're often talking about a more traditional east-west communication, meaning of things like a programmable logic controller or PLC pulling information from its I/O, or an HMI pulling information from the PLC. Oftentimes communications that don't leave the access switches where these end devices are connecting in the first place. Historically, this has meant organizations have needed to stand up dedicated out-of-band networks in order to get all the traffic back to some centralized location, which is expensive both from the need to deploy additional hardware and additional cabling, as well as the management overhead that's associated with it. Cisco CyberVision runs directly on the networking equipment where the end devices are connecting in the first place, eliminating the need for additional cabling or additional hardware, and providing full visibility into all the communications that are occurring. Today, Cisco CyberVision is supported on our industrial Ethernet or IE3400s and our IE3300s, as well as our industrial IE9300s and our enterprise class 9300 and 9400 switches. It's also supported on our industrial routers, including our IR1101 and the IR8300, enabling the ability to get full end-to-end visibility of all the assets in the environment. Cisco CyberVision can also leverage active discovery, meaning the ability to generate requests in the industrial protocols that these devices are communicating to ask for additional details. CyberVision's active discovery is done at the sensor level, meaning things like firewall boundaries or network address translation won't actually block these requests, enabling the ability to get full end-to-end visibility of all the assets that are deployed in the environment. For brownfield environments, with devices that don't support hosting the sensor, we do also offer our Industrial Compute or IC3000. This is a ruggedized form factor, DC powered, DIN rail mountable, meant to live inside of the controls cabinet device that has the ability for you to span traffic from your existing infrastructure to it for the sensor to perform that deep packet inspection and send its information back to the center. Again, because we're not sending all of this traffic back to a centralized location, the existing network infrastructure continue to be leveraged for this purpose. As discussed, CyberVision provides flexibility for deployment, whether it's running directly on the network equipment where the end devices are connecting, leveraging the Industrial Compute or IC3000 for span-type solutions, or for environments where there already is centralized communication, the sensor functionality can be ran directly on the center itself. With that said, let's see it in action. As discussed, the CyberVision Center is the main interface into the solution from a user perspective. It's where integrations occur, both with Cisco as well as third party, as well as the ability to leverage a fully RESTful API for interacting with the tool. When I first log into the center, I am greeted with a primary dashboard. The dashboard is broken into two sections. One focused more on operational information, the other focused more on security. On the operational overview, I can see information such as a breakdown in terms of the types of protocols that have been discovered, a breakdown in terms of the events inside the system, as well as the ability to pin or select a set of favorite presets that will show up at the bottom of the screen. We will dive deeper into presets, but presets are essentially a set of filters. It's a methodology that allows me the ability to filter the information inside the system. We can see here that for each preset that I've pinned, I can see information including the risk score for the preset itself based on the average of the devices that have been identified. And again, the risk score is really one of the main ways as a user I can help identify where do I get started, where are my riskiest devices in the environment. We can also see details as far as when the last information was calculated, the number of devices that are matching that preset, the number of vulnerabilities, as well as the number of activities that have occurred. On the security overview, we can see information including a breakdown in terms of the number of vulnerable devices inside the system, as well as their criticality, the risk scores that have been identified for the devices, and the criticality of those risk scores, the more critical events, as well as the breakdown of the categories of those events. And again, I do have the ability to pin or select my favorite presets here at the bottom, and you'll notice these can be different than the ones that are on the operational tab, so I can have different presets based on my different use cases. Going to the Explore section, we can see the presets that are defined inside the system. As mentioned, a preset is a set of filters. It's a methodology for me to actually reduce the information that I'm seeing in terms of the devices and the communications between those devices. By default, out of the box, there are a set of filters that are based on information like all of the data, or OT focus views or IT focus views based on the types of devices that are seen, or OT activities or IT activities based on the types of communications that are seen. This realistically allows me to start initially filtering based on the high-level information in terms of types of devices or types of communications that I've seen. However, I do also have the ability to define my own custom presets. And presets can realistically be driven based on your use case and the type of information that we wish to see. If we come over here to my paint preset, what we'll notice that for each preset, I'm first greeted with a primary dashboard. This is going to give me information as far as the overall risk score of the preset itself based on how it's been filtered, the types of devices or number of devices that I've seen, the activities between devices, which an activity is the communications between devices themselves. So an example, if I go online with a controller with a programming workstation, that online would be a single activity. I can also see the number of vulnerable devices that are matching the filters, the number of events that have occurred within the filter, as well as the variables that are associated with those devices. If I was seeing clear text passwords going across the environment, I'd also see those being identified with the credentials that are seen here. Now, one point to bring to your attention is the tagging structure that's built into CyberVision. By default, automatically, as CyberVision sees the devices and gathers information, as well as the activities or communications between devices, it will associate the relevant tags. Tags are used in a couple ways inside the system. First of all, tags are one of the ways that I can filter. So if I wanted to see any device that's been identified as a controller, I could use the controller tag as one of my filters in the preset, which would reduce the amount of devices that I'm seeing to only those that have been tagged as a controller. The other piece is that a tag allows me the ability to quickly up-level information. So for example, the read variable or start CPU, those can look very different depending on the protocol in which they're being communicated in. For example, in a Rockwell world with Ethernet IP, or a Siemens world with Profinet, or in a Schneider world with possibly Modbus, each one of these are going to look very different. But without me needing to become a protocol expert in every single protocol that's in my environment, I can simply see, independent of the protocol, which type of command or which type of activity is occurring for that device. The last piece is tags allow me to quickly pinpoint information throughout the system, and we'll see that in action as we move forward here. Some of the other filters that are available, first of all, I can filter on the risk score. So if I just wanted to see devices that have a score of 50 or above, for example, I could filter that down and just see that level of detail. I can also leverage my network information as part of my filtering. So if I wanted to see a specific subnet or a specific VLAN, it allows me to get that information or filter again based on those specific details. As discussed, I can leverage the tags as my filtering criteria as well, which is really more of a process-driven approach, using information such as the types of protocols that are in use or types of devices that have been identified or the activities between those specific devices. I also have the ability to leverage the sensor itself as my filter. So depending on which sensor is observing the communication for this device, I can match that information based on my filtering criteria, which is really more of a zoned-based approach. It allows me to see exactly what devices are being observed in what area or what portion of my facility. Moving from the dashboard to the map view, we can see here a logical representation of the devices that have been observed and that are matching the filter criteria. Some things you'll note is, first of all, I do have the ability to group resources, and I do have the ability to nest groups. So in my example here, I have the paint group, and within inside the paint group, there is my cell 1, cell 2, and cell 3. This gives me that ability to, again, to more logically refine or define how devices are related to each other. The other piece, when I'm defining a group, is I do have the ability to define the industrial impact. So if this is a set of devices where if they were to go offline or be compromised, it could mean people have to go home or human life is at risk. That's more of a 5 out of 5 or a high industrial impact. However, if this is a device where it can go offline and we have enough materials queued or it's not going to impact any type of human safety, that might be a 1 out of 5. The industrial impact is my way of communicating to the system how critical a resource is. This is primarily leveraged for the risk score calculation as part of that likelihood versus impact. Within the map view, we're able to see a representation of the devices that have been observed and the communications that are occurring between them. You'll note that the color coding will depict the types of communications or activities that we've observed between these devices. And by default, we're going to summarize the group-to-group communications, giving us again more of that zone conduit type of approach. However, if I did want to see each individual connection, I could simply check the show network activities, and each device-to-device communication will be represented. Some other information you may be noticing, many of these devices have a red circle with a white number inside of it. This is the number of vulnerabilities that have been associated to this specific device. So this helps me quickly pinpoint or identify devices with vulnerabilities associated with them. If I select a device and go into the details, first of all, you'll notice that I do see all the information that CyberVision is learning about this specific asset. Details like the firmware version, the IP address, MAC address, the type of hardware, the model reference, the name that's been associated, the serial number, the vendor, the VLAN that's associated with the device. As well as in this case, because it is a modular system, I can see the various modules that make up the platform itself, as well as details such as, in this case, being a programmable logic controller. I can actually see the name of the program that's running inside of this device. Moving to the Security tab, we can see the vulnerabilities that are associated with the device. For each vulnerability, we'll see the name of the vulnerability, the CVE number that's associated, the details as far as what the issue is, as well as if there is a possible workaround, what that workaround may be, as well as when the issue was published, when we first identified it against this specific device, and why we're matching this information to the device. CyberVision will also provide links to external resources, including the vendor or even ICS cert, which allows me to gather more details about the vulnerability. Each vulnerability will also give me the CVSS score, as well as the version, and the types of access that are typically leveraged to use that vulnerability. For each vulnerability, based on the criteria that is matching, we'll determine exactly how I can resolve the issue. So for example, if it is tied to a firmware version, let's say this device is running version 31, and Rockwell was to release a version 32 that has a fix, just by going through the process of updating the device and modifying the firmware, CyberVision will see that update occur, it will see the device begin operating with that new firmware, and the vulnerability would no longer match, so it would simply fall away. However, if this is a vulnerability where it doesn't have a fix or a firmware change is not the answer, or possibly you've put in some other kind of mitigating control into place, such as a firewall rule to block web access, or whatever it may be, any type of change that won't be observed by CyberVision, I do have the ability to acknowledge the alert. However, because the criteria is still being matched, the alert will still show, or the vulnerability will still show against this device. However, I can see who did the acknowledgement, when they did the acknowledgement, and what type of comment was left. So things like compliance and auditing can easily be pulled from the system and leveraged for those types of activities. Moving to the risk score, here's where we can see how risky this specific device is. CyberVision will calculate a value from 0 to 100 based on the likelihood and the impact of any type of compromise to this device. Some of the criteria that goes into that scoring includes the type of device that it is, the group impact or that industrial impact that we discussed, the activities that are observed against the device, and the vulnerabilities that have been associated. We can also see if I was to take all of the recommendations that are given, the best possible score I can get for this device is a 37, which allows me the ability to quickly see how much I can change or what impact I can have on that overall risk score for the device. The risk score is really meant as a method to allow me the ability to compare against other devices in the environment to help me identify those riskiest devices, or again, where should I get started? If we move to the activity view, here we'll see a very similar look and feel. However, in this case, it's all from the perspective of this device and will not follow the actual filtering criteria of the preset itself. So we can see all the connections that are being made. And at the bottom, we can see the specific activities. And here again is where the tag allows me to quickly pinpoint the types of information that's being observed. So for example, here I can see this is the activity where the actual block download or a start CPU command was sent to the specific PLC. Moving to the automation tab, here's where you can actually see the variables or what's being communicated between the devices. In this case, we see two variables that are being exchanged from the other controller, as well as one that came from a programming workstation. For each variable, we can see the protocol that was used, the type of connection, the type of access, was it a read or was it a write or was it both, as well as when was the first time we saw that activity and when was the last time we saw that activity. Returning to the map, one thing you'll notice throughout the tool is there are methods to actually export the information. So for example, with more of a graphical view like the map itself, I do have the ability to export to PDF in the top right, or if this is something where it's more of a tabular view or more of a data view, I do have the ability to export to CSV. Moving from the map view, we can also see we have a device list, which gives me a breakdown of all of the devices that are matching in more of a tabular view, as well as an activity list, which will show me the device-to-device communications that have been observed by the preset. Moving to the vulnerabilities view, here we can see all the vulnerabilities that are matching this specific preset. At the top, we get a breakdown in terms of the top 10 that are matching the most, and at the bottom, we see all those vulnerabilities listed. This does give me the ability to filter based on title, the CVE number, or the CVSS score, as well as a breakdown in terms of the number of devices that are being impacted by this specific vulnerability, allowing me to have more of a holistic view into all the vulnerabilities that are associated with this specific preset. Moving to the security insights, here's where we can see information as far as the DNS request or HTTP request or SMB information that's being observed in the environment. We will see a breakdown in terms of the DNS request, in terms of the most frequent, as well as the rarest requests that we're seeing, and similarly information for the HTTP details, as well as the SMB connections that are being observed. This view allows us to quickly pinpoint any types of misconfigurations or issues that might be occurring in the environment. One example is that many organizations do not allow remote access into the facility or do not have a defined solution. In many cases, we can come to this tab and see DNS requests being made to popular free remote access solutions, which is obviously a compliance or a policy violation. Being able to quickly pinpoint this information helps us identify those types of issues. Once Cybervision has been deployed, the groups have been identified, and my presets have been defined, I then have the ability to create a baseline. Baselines are my methodology for informing the system this is what normal looks like. Should something change, alert. One of the benefits of Cybervision's baselining is they are associated to the preset, so any filtering that I've put in place for the preset will also be used for my baselining functionality. I also have the ability to create multiple baselines. So in an environment where I have different production runs with different equipment online, or even just a production versus maintenance approach, this allows me to tie external context into my alerting. So if I'm in production and seeing maintenance alerts, that's something I need to investigate. But if I'm in maintenance and seeing production alerts, that's probably something we can ignore for this time. Here we can see I've created one baseline called production 1, and there's actually 22 alerts that have occurred. If we come over here and go to what has changed in my activities, again, we can see the power of the tags. This allows me to quickly pinpoint the types of information that's being observed as part of that baseline. In this case, we can see there's a write variable. And if we go into the details, we can see that at the time that the baseline was created, the sync variable or tag from a Rockwell perspective was being communicated between these two controllers. The sync tag was being read and written. However, since that baseline's been created, the sync new 1 tag is now being exchanged. I like to show this example for multiple reasons. The first one being that the sync new tag is actually a boolean. So if I wasn't doing deep packet inspection and didn't understand or decode the protocols, identifying a single bit change at a network level would result in a multitude of false alarms. But because we're doing this deep packet inspection and actually understand or decode the protocols, we're able to quickly pinpoint the fact that a new variable is being exchanged. For any baseline alert, I do have the ability to simply acknowledge the alert itself, which will essentially allow it to be folded into the change. So going forward, Cybervision would expect this variable to continue to be communicated. However, if this wasn't something I expected, I also have the ability to report it as an issue so that someone from the security team can take a look and understand what kind of changes occurred and why. The major benefit here is this allows me to continue to modify and grow my baseline over time. So I don't have to go through a relearning phase or start from scratch. That information can continue to change as the environment changes and as new devices come online. As mentioned, the baseline is going to look for changes in the environment. So a new device coming online, a new communication between existing devices, or even new variables between those devices will trigger a change in the baseline. The last piece is I do have the ability to search for information inside the system. So for example, if I wanted to see all of my devices that are running version 31 of Rockwell firmware, I could simply search for that 31, and now every device that has that firmware associated would show up in my list. For any search that I've done, I do have the ability to save that search as a preset so I can access it again going forward. As discussed, Cybervision can provide organizations visibility into the assets that are deployed in their industrial environments, the communications that are occurring between those assets, as well as any types of vulnerabilities that have been associated to those devices. This has been a quick overview of the solution. I appreciate your time. Thank you.